Okay, so if I want to factor a trinomial, three terms, where the lead coefficient is not 1. It's 2 in this particular case, but anything where it's not 1, we actually have a couple of options. So what we could do, well, of course, the first thing you always want to look for is there a common factor? So is there a common factor among all three terms? And in this case, the answer to that question would be no, that there is not a common factor to all three terms. So then I'm looking at a trinomial and trying to determine how might it factor into two binomials. So if it factors into two binomials, it would factor, well, we could start off by writing our two parentheses. And we can think about, well, how would the first two terms have to make this 2x squared? They have to multiply together to make that 2x squared. So for 2x squared, we don't have a lot of options. We really only have the options of 2x and x. If this was not 2, if this was not a prime number, we might have other options. But since we only have two options, we'll just start with 2x and x. Now I know when I multiply those, FOIL it out, expand it out, 2x times x would give me that 2x squared. So that's how I get started with this first method, trial and error. Now, I am now going to try to figure out what would I put here and here in order to multiply those two together and get negative 12. But this middle term is the one that's really going to kind of guide my work as I decide which factors of negative 12 to put in here. Because when I expand this out, the product of these two plus the product of these two terms has to give me a negative 5x. So if that's the case, I have to think about what are my options. So if I take negative 12 over here to the side and I think about what are some options that I could have for putting here and here? What are some factors of negative 12? So of course I have 1 and negative 12. I've got negative 1 and positive 12. Since this is a negative 12, we have those two different options. And if I want to just write an exhaustive list, I can do that here. I don't necessarily have to. As soon as some options come up over here that I think I might want to try, I can run over here and do some trial and error. And the more you do of these, the faster you'll get at seeing the number combinations. But in the beginning, or even when you get stuck after you've done 100 of these problems, you can always go to this exhaustive list to kind of give yourself a starting place. So if we've got 1, negative 12, negative 1, positive 12, we've got 2, negative 6, negative 2, positive 6, 3, negative 4, negative 3, positive 4. And at that point, as I'm going through, I went 1, 2, 3. If I went up to 4, so if I started to write 4, I would immediately see that it's 4 times 3, and I'm starting to cycle back through. So that's actually where I'm going to end the list. I don't need to write that last one down. So now I'm going to think, okay, what could I place here and here, keeping in mind my goal is that whatever I multiply these two together with gives me a negative, whatever I get here, whatever I get after I multiply these together and I add, I'm looking for that negative 5x. So right here I would think, okay, 2x times something and x times something. So I'm thinking about, here are all my options for what to put in there. And as I'm looking at that negative 5, I'm thinking to myself, well, if I put a 4 right here, so I'm going to go ahead and just put it. If I put a 4 here, 2 times 4 would give me 8. So this would actually be 8x. So I could write 8x. And if I used 4, then negative 3 is the other factor. So I could put negative 3 here, and that would give me a negative 3x when I multiply those together. So thinking about what is that going to end up being, when I add those together, I get 5. Positive 5x, I'm really close. I'm not quite there. I'm really close. I've got a positive 5x. I need a negative 5x. So I would come back in here and I'd think to myself, oh, I forgot to put the positive there. I would come back in here and I'd think, what if I changed the signs? What if I made this a positive 3 and I made this guy a negative 4? And if I did that, these signs would change, positive 3x, negative 8x, and there is my negative 5. So that was all kind of my scratch work, my thought process. If 3 and 4 didn't work, then I could try 2 and 6, 1 and 12, and I could kind of play around and do some trial and error. My final answer, since I've kind of made some notes up here, my final answer, I'll just rewrite it, 2x plus 3 and x minus 4 for this factor. Okay, that's called trial and error. There's lots of ways to do this. You could have used, there's also the box method that you could use. You could think about, okay, I'm trying to come up with 2x squared and negative 12, and you can kind of fill in, you can go x and 2x and then use the same essential strategy that we did right here. It's just a different way to organize your work. So you can use the same essential strategy, list your negative 12s and start to fill in, thinking about, well, what if I let this be a negative 4 here, then that would give me that negative 8x. If I put over here, if I had negative 4, I'd have to have a positive 3. X times positive 3 would give me a 3x. Add those together, and there's that negative 5x we're looking for. So that's just another way to kind of organize the work if you like the box method, if you like just going to the binomial method. All of these are utilizing a strategy called trial and error. There is actually another way to do it called the AC method, or the factor by grouping method. So if you wanted to, you could also take 2x squared minus 5x minus 12. And the AC method goes something like this. So the AC method would say, take your A and your C. So take A and C, 2 times negative 12. So AC is 2 times negative 12, which is a negative 24. And then look at negative 24 and think of all the factors of negative 24 that we have. So you've got your 1 and negative 24, your negative 1 and positive 24, you've got your 2 and negative 12, your negative 2 and positive 12, and you actually keep going down this list. You can make an exhaustive list, but the goal, what we're going to be looking for here, the goal is to find two numbers whose sum is equal to b, b being the number here in the middle. So we're always trying to get to that middle number. So we're looking for two numbers that have that sum of negative 5. So in this case, for our particular case here, that's going to be negative 5. For our particular trinomial, it's going to be negative 5. So you don't have to write the exhaustive list if you just start thinking of the factors of negative 24 and if you can come up with them right away. And so I'm thinking, oh, well, that would be negative 8 and positive 3, because when I add those together, I do get negative 5. So that's the pair that I'm going to work with. And this is the part that then you have to be a little bit careful, because we're going to use these two numbers to actually break up negative 5. So we're going to come over here and we're going to make a little tree here and break this up into a negative 8x and a positive 3x based on what I found on this side. So negative 8x, positive 3x, everything else is going to carry down. This is actually going backwards of expansion or backwards of foiling. So now we've got 4 terms. If we were going the opposite direction and just multiplying out 2 binomials, we would move up here and we'd combine those 2 middle terms. So we're kind of having to think backwards here is essentially what we're doing, going backwards from a compressed combined trinomial backwards into one that has been expanded out and still needs to have the like terms combined. And we're going to continue going down that road of working our way backwards into the full factored mode. So at this point, we're going to factor these terms by grouping, group in pairs, and look for a common factor among each pair. So here we've got a 2x. So this is going to be equal to 2x. Pull that out. That'll give me an x minus 4. Common factor between these two terms would be 3. And it's a positive 3. You do want to take the sign with you, so pull out a positive 3, leaving me with an x minus 4. And conveniently now, when we did that, we have a binomial that's a common factor. We can factor that out, x minus 4 and 2x plus 3. And there is my factored form. So notice two very different sort of strategies here. Here was the trial and error. Trial and error utilized some just, some guessing and checking, and we had to play around with the signs, and we had lots of options. Again, like I said, with trial and error I think is often the faster way to factor trinomials, especially after you had some practice. But some students really like this AC method because it gives you a little bit more of a structure on how to factor these. But either one works, and really it's about finding what works for you. So notice again, though, we did get the same factoring here in both cases. Doesn't matter when you write the product, the two factors, the product of the two binomials, it doesn't matter the order in which you set up those binomials. So these are equivalent answers here. This one just has the 2x plus 3 first, and this one has the x minus 4. All right, I hope that's helpful.